Designs with Utex Industries, and I'm here with Gabriel Morales. Gabriel, would you like to go ahead and introduce yourself?
Yeah, good morning, Jennifer. Thank you for the intro. So previously, I spent a lot of time, working with materials, helping develop materials for oil and industrial applications, composites, polyolefins, rubber, etc. I started with Utex about 3 years ago in their lab, and recently I've joined their technical sales team.
Awesome. So you have a lot of background with urethane, then, is that correct?
I've had some very nice opportunities to work with them, especially with some offshore applications as well, manufacturing also.
Okay, perfect. Well, that's what we're going to focus on today is kind of our urethane processing, which we do out in our Conroe facility. So can you tell us why would a customer come to us for a urethane product?
Abrasion and wear resistance, that's typically what people are looking at. If you think a very common example like a skateboard wheel, they're handling the weight of a full-grown person rolling along hundreds of miles, and they're still there. They cushion, they receive impact. It's that people are really looking for, is just that long-term kind of longevity, and then still being able to maintain the basic shape. You also have cost. You're able to minimize waste because you can actually take a fixed volume and produce just that amount that you'll be filling into the mold. It's not something that you're going to have too much flash or waste on. It does have good resistance to oil and solvents. Handles loads very well, so you're going to see it in things like rope coatings where they're going over pulleys. So that weight, coupled with its ability to resist the abrasion of a pulley, is a major advantage. It has good impact strength. It's very flexible. You can also tailor the hardness to it. So depending on how you mix, because this is really a, kind of a part A, part B type of reaction, you can alter chemically how you're going to get that final result.
When it comes to the characteristics of the urethane, you already mentioned that it's really good oil resistance, wear resistance. What about temperature?
Yes, it does have its limitations. So something that, I can kind of jump into a similar topic that, runs alongside this. There's also something known as thermoplastic polyurethane, or TPU. Utex does handle that. That is a product that you can actually soften, lower its viscosity, mold, and the final product is only going to be, as durable in temperature as the temperature that you molded it at. So it has that limitation. With the cast urethanes, you're forming a permanent reaction that will not revert to its original state. So that gives you a little bit of a better handling. You can look at, between 200 to 275 Fahrenheit, which is kind of just below where rubber usually picks up on. So you do have, above a boiling point type of temperature handling.
So you were just mentioning the process. Can you tell us how Utex processes the urethane?
If we're going to be mixing kind of in a batch size, that's something that most people are familiar with. Like I mentioned earlier, you take a part A and a part B, mix it in a batch, pour, and you get your part, but you're also going to have some waste. You don't ever want to undermix, because if you end up with a mold that's short of the resin, then you didn't complete your part. And it's difficult to go back and remix and do that again. So Utex is very well set up with mixing equipment. So depending on the ratio, of what you're doing, you can either have a material that's going to come out, of a high hardness, or something that's a little more flexible. The metering devices are able to do this automatically. If you will, the silos or any type of containment that we have for the resins will feed into a machine. We can alter that ratio, and it's going to come out of a small nozzle. That small nozzle can have the mold directly under it, and you can actually move it around and have very accurate product placement. When you're done with that mixing portion, you cut the machine. You purge, you're done. You don't have, massive containers that are dripping and full of resin, et cetera, and you're going to get a very, very precise ratio every time. Plus, we can always go back and look at the run data and make sure that we actually did that. So you're going to be able to tailor your hardness. You're going to be able to, color. If you want more intensity of one color or another, you can meter that as well. So that's, it's a good way to be able to have good control and repeatability.
Okay, and then going further into, Utex and our urethane capabilities. Can you tell us a little bit more about the facility, like, what the square footage looks like?
Yeah, so it's typically you'll see kind of a division on the mixing side. You're going to have an area in which we're storing the material. We usually keep that above ground. And you also have an area where you allow materials to kind of settle down as they're curing, as we call it, when the resin is starting to, form to its final hardness. We also have a section that has ovens as well. Some materials just need that extra kick, to make sure that they reach their full cure. We're kind of looking maybe about, 7,000 or 8,000 square feet total. So there is a good dedicated area to this.
Right, especially because not only do we urethane there, but we also have our rubber that we manufacture out there as well.
That's correct, yes. And machining too, you've got metal shavings and everything. And so urethane being a more delicate process, we do have a nice facility to isolate it away from those other processes.
Okay. Would you be able to add a little bit more on why choose urethane over like a rubber product?
Right. So that's, you can look at it in two different forms of cost savings. One of them is going to be that initial tooling cost. The other one is in the material itself. So earlier we talked about how you can save by metering just the right amount of urethane for a mold. So if, let's say that you have a mold that's compressing for rubber, you're going to have flash, you're going to have, or an injection molding, you're going to have runners that fill up with material just so that you can get the mold cavity filled up and get a proper part out of it. You want to, make sure there's no bubbles in there, that there's nothing entrapped that's not going to give you a complete part. With urethane, you can do the same thing, except that you're metering an exact amount for it. And as far as molding goes, we talked about urethanes having a temperature limitation somewhere in the 250 to 275 F. Likewise, you're not seeing very high mold temperatures as well. In fact, you can pour a resin or cast it at a room temperature. So the molds do not have to see the types of pressures and temperatures that rubber molds do. So you can use composite molding. I can take a plug, I can make kind of a gel coat and fiberglass encasement, cut it in half. Now we have two cavities. They're inexpensive, they can be done within a couple of days. And you can get either full use products out of it, or you can do prototyping from there as well. So you're saving on tooling and you're saving on the materials itself.
Okay, and so when it comes to the prototyping, standard lead time on our urethanes really 2 to 3 weeks. It generally just depends on our quantities. But what about when it comes to R&D type work? How quickly can we do something like that?
Yeah, R&D work is simplified because you're not looking at big tooling costs or time as well. I've seen parts that are cast inside of cardboard boxes. You can do Lego bricks. Or you can take aluminum slabs, form an encasement, and work from there. You can make solid parts, machine them as well, because urethane is machinable. So you have a variety of options to look at when you're prototyping parts. So they get out quicker. You're not being held back by having to purchase steel, having to machine it, having to condition a mold, or even the molding time is reduced as well because you're just casting and letting it set up. So it's a quick way to get parts made. Sometimes you just need to see the fit of something. You can do that as well with the urethane, and you can always go back and machine it down. What we made in urethane might be useful to the customer. Ultimately, they might want to step it up in terms of like temperature handling, or in some cases chemical resistance. Then we look at other materials. But a urethane can get us going in the right direction quickly. We want customers to keep us in mind when you're looking at the early stages of development. It's not something that we have to wait until you have the absolute final product and then for us to come in and quote a full production run type of quote. No, we can actually work with you to prototype. We can start at those early stages. Just to let us know what the end goal is. We'll look at the different materials that can help you get there.
All right, Gabriel. Well, I appreciate you taking the time to do this video with us today. Hopefully we'll have some people reaching out for some urethane products.
We would look forward to it. We'll be willing to work with anyone on any questions as well. So.